Hello guys, welcome back to our series on Bluetooth Low Energy. This video will be in continuation with episode 2, where we studied about the advertising parameters. In that advertising parameter structure, there are two members, that is advertising interval minimum and maximum. So we will understand the advertising interval and the concept related to it, like advertising event, advertising delay. We will also learn about how and what packet collision is with an example. After that, we will see how to calculate advertising interval in ESP-IDF. So ESP-IDF has provided a formula to calculate the advertising interval. This calculated advertising interval we will configure using ESP32 S3 development board and sniff live packets, and we'll check that the advertising packets are transmitted as per the set advertising interval time. So stay tuned and let us understand what is advertising interval and advertising event. The advertising interval determines how frequently a device broadcasts advertising packets on advertising channel to other devices. As you can see in the figure, 37, 38, and 39 are the advertising channels. So if the advertising interval is set of suppose 1 second, so every 1 second, the device that is advertising will advertise the packets on these three channels. Once the 1 second time is reached, then again the same process occurs. The smaller the advertising interval time is, the more frequently the advertising packets are sent, and consequently, more power is consumed, and vice versa. If you are working on a battery constrained device where power is the concern, then in that case, if you advertise very frequently, then your device will wake up more frequently to advertise the advertising packets. So if you are working on a power constrained device, then your advertising interval should be maximum. If your target is to achieve less power consumption, then let us see how this works. So suppose my advertising interval is set to 1 second. Then in that case, once the device start advertising, it will advertise on 37, 38, 39 channel, and it will go in deep sleep here. It will remain in deep sleep, and once the 1 second time is reached, it will again wake up. It will advertise on 37, 38, 39 channel, and again it will deep sleep. So your power, once it goes in deep sleep, your power will be saved here. Now consider my advertising interval is 2 seconds. So after going deep sleep here, it will not wake up here because my advertising interval is 2 seconds. It will wake up here. So double power will be conserved as compared to advertising interval set to 1 second. This is the concept. The third is the advertising interval defined by the Bluetooth special interest group is in the range of 20 millisecond to 10.24 seconds. It is an integer multiple of 0.625 milliseconds. So let us understand what this Bluetooth SIG is. Bluetooth SIG is the International Standard Development Organization responsible for Bluetooth technology. It looks after the development and license of the Bluetooth technology. So for an example, you are having Bluetooth headphone and any mobile of any brand can connect to that headphone. Why? Because that is qualified by the Bluetooth SIG, means both your mobile phone and your Bluetooth headphone stack, Bluetooth stack. I'm not talking about application. The Bluetooth stack is qualified or is built as per the guidelines given by this Bluetooth SIG. So where are these guidelines there? Bluetooth SIG publishes a Bluetooth core. It is a document of thousands of pages. Referring that document, you have to build your stack, and that is to be qualified from this Bluetooth SIG. When you build the stack, the advertising time interval should be in the range of 20 milliseconds to 10 seconds. So just for an example, you can see my advertising interval is of 20 milliseconds. So from 0 to 20 milliseconds, and there is a advertising delay of 3 milliseconds. So after 23 milliseconds, second advertising event will occur. So advertising interval plus advertising delay combiningly called as advertising event. Now if you see second advertising event, it is 23 plus 20 milliseconds, that is 43 milliseconds plus a 5 milliseconds of advertising delay. So why here the advertising delay is of 3 milliseconds and why here it is of 5 milliseconds? Why this is such a random behavior? Let us understand in the subsequent slides. The advertising delay is a pseudo-random delay with a range of 0 millisecond to 10 milliseconds generated by the link layer for each advertising event. So this is also a guideline given by the Bluetooth SIG, which is mentioned in the Bluetooth Core Specification documentation. You can comment it. I will provide you the link for this Bluetooth Core Specification document. So that is why here it is the random behavior. It is 3 seconds, it is 5 seconds. We will see when we sniff the live data if this behavior is actually there. So then a second concept here is how and what is collision in Bluetooth. So sometimes when you advertise at a fixed rate, here we are advertising every 20 milliseconds. So this is a fixed rate. Sometimes when you advertise at fixed rate, it increases the possibility of collision in the air, like if other devices are using the channel or collision from Wi-Fi or other 2.4 gigahertz signals. So if there are multiple devices Bluetooth, as Wi-Fi also works on 2.4 gigahertz, Zigbee is also there, which also works on 2.4 gigahertz. So if you are having multiple of such devices in one location, then there are possibilities of packet collision. So how packet collision occurs? So let us see one example. Here we are having two device A and device B, and a smartphone which will act as a scanner, and these two devices will advertise the data. The scenario here is that both the device will be advertising on advertising channel 37 at the same time. So the communication between this ESP32 devices and the smartphone will be over GFSK, and the data will be sent bit by bit. So first bit 1 of device A and bit 0 of device B will be transmitted on the advertising channel 37. So here it can be 01 as well. Just for example purpose I am telling you. Similarly, bit by bit each data will be transmitted, and this will be a 2 byte data, 1 byte of device A data and 1 byte of device B data that will be scanned by this smartphone, which will be a corrupted data because there is a specific advertising packet format. The data is not as per the packet format, so the data is corrupted. So there will be packet loss here. If this happen consistently, if consistently both A and B are transmitting on a channel at the same time, then the advertising packet from either of these devices will never reach this scanning device, the smartphone. So to overcome this, a random advertising delay that we saw is added after the advertising interval. In that case also there is possibility that both the devices, even after having the advertising delay, random advertising delay, there is possibility that both the devices can transmit at the same time on the same channel, but the probability becomes less. So now let us see how to calculate the advertising interval in ESP-IDF. So to set this advertising interval min and advertising interval max, this is the formula that is provided by the ESP-IDF. That is time is equal to n into 0.625 milliseconds. As we have seen, this 0.625 term is defined by Bluetooth SIG itself. So n is in the range of hexadecimal 20 to hexadecimal 4000. So this is also given by ESP-IDF. If you set this outside of this range, the advertising interval will fail and the device will not advertise. If we set n to this 20 hex, time will be 20 milliseconds, and if we set the n to 4000 hex, the output will be 10.24 seconds. So this is in the range of 20 milliseconds to 10 seconds, which is also defined by the Bluetooth SIG. So now we'll just take an example. Suppose you want to advertise at an interval of 1000 milliseconds here. So if you consider this formula, 1000 is equal to n into 0.625. So I have to calculate n here. N will be 1600 in int and 640 in hex. So we will set this advertising interval min and max in our code to 0x640, and we will check on the sniffer that we are receiving the data every 1000 milliseconds. So let's head towards the specified E. So this is our get server example. So we will set these two advertising interval min and max to 0x640. Okay. Rest configuration, we are keeping it as it is because we are currently focusing on this advertising interval part only. In the upcoming video, we will see the other configurations as well. There is one more change that we will do. We will just advertise on a specific channel. It will be easy for us to check the advertising interval on the Wireshark. Let us flash the code. So the code has been flashed. Now we'll open Wireshark. There are many Bluetooth devices in my location. So I will filter the one that is the ESP-IDF one. How to filter the specific source or MAC address I will tell you here. Okay, so this is here just enter btle dot advertising underscore address equal to and your Bluetooth address here. This is my Bluetooth address EDDA. Just hit enter. Okay, so it will show you your address only. So the second setting is go to view time display format. Set this to milliseconds and here set the seconds since previous displayed packet. So it will show you the time since previous displayed packet. So the time difference between the previous packet and current packet. Right? That is what we need. So here you can see it is 1 second, 1.1 point. So this is 1 second and this is milliseconds. So you can see here a random delay. In milliseconds, there is a random delay here, right? Here there is after one there is 3 points. So there I'm thinking there might be some packet lost here because there are multiple BLE devices and Wi-Fi at my location. But there is not much packet drop. That is only two packet is drop here, one packet is drop here. So it is acceptable. You can see the advertising delays. So now let's pick one of the packet. Going forward, I will explain you this packet in detail, but just for an overview, like you can see this channel index 37. So here we have set our channel to 37. That is why it is displaying 37 here. So this we will skip for now. Going forward, I will explain you this packet. So there is a random delay. That was the one important thing I wanted to show. So where can you get your this advertising addresses? You can go to this terminal and see here this Bluetooth MAC address, right? So you can copy this address and you can paste it in here and you can filter out the expressive packets only. So the only expressive packets will appear here. So now let's see if minimum and maximum interval are set at different time. So this is set to 1000 milliseconds. We'll set this to 960, which is 1500 milliseconds. Now let's see the behavior of the device when we set this min and max interval to different time. So let us check on Sniffer. You can see it is advertising after every 1.5. So it is taking the maximum time for advertising interval. And plus there is also a random delay here. You can see 501, 504, 500, 506. So there is a random delay here. Now let us check one more scenario that what if I keep this outside the range. So if you go here, see the formula that we were talking about, we just understood. See, the range is from 20 to 4000 hex, right? So what if I keep any minimum or maximum interval greater than this value or minimum interval less than this value. Let us check what will happen. So now it is not 1000 milliseconds. Let us flash the code. You can see here invalid advertising interval parameters, advertising start failed. So you can't keep this interval minimum maximum outside the range specified by this ESP-IDF. So that is it for this video. If you find this video helpful, do like and share this video and don't forget to subscribe our channel. Thank you.